Hello, today we'll see the circuit full subtractor. Half subtractor we have already seen in the last videos. Half subtractor, what it does, it will take two binary bits and it will subtract, generate difference and borrow. Now here it is the name is full subtractor. That means it must be taking care of the borrow generated in the previous column of the subtraction. So what are the bits? Binary bits, it is subtracting A, B. Now instead of borrow give the name as a CI only, so that the full adder and full subtractor circuits similarities will be seen. That's why. Otherwise it is actually a borrow, but we name it as a CI, that you please remember. So three inputs A, B and CI, and what it generates the output is a difference, that means subtraction output, and the final borrow. What is the meaning of this final borrow and all? Suppose A is 0, B is 0, 0 minus 0, this is a difference 0, and the borrow generated is also 0. Suppose the borrow is generated there, so if the CI is 1, so that 0 minus 1 I have to do. So 0 minus 1 will be 1, so final difference is 1, and then here 0 minus 1 as per binary subtraction rule, 0 minus 1 is 1, difference is 1, and borrow is also 1. So it will generate this as a difference and this as a final borrow. So in this way the subtraction will be done by using this circuit. This is a full subtractor block diagram only. Now we have to design the circuit. Now for the design, again a truth table is required. Truth table means again input output combinations, possible combinations. So the truth table is already done over here. Inputs A, B, Ci, outputs difference and borrow. Now again as 3 inputs are there and 2 raised to 3 is 8. Why 2? Because it is a binary, that's why the base is 2. So 2 raised to 3 means 8 combinations will be done. So all the 8 combinations are listed here. 0, 0, 0, the sequence goes in the ascending order, you all are aware. Otherwise if you want to remember like this, you can remember this way. A and B are 0, 0, borrow is not there, so the combination is 0, 0, 0. Next combination, A is 0, B is 0, but borrow may be there, so 1, so that's why it has become 0, 0, 1. So same way it goes ahead till 1, 1, 1. So these are the 8 combinations listed over here. Now for that, what is the difference and borrow, that we have to find out. So first, if A, B and Ci all 3 are 0, naturally the difference will also be 0 and the borrow is also 0. If it is 0, 0, 1, the same thing I have done over here. If A is 0, B is 0 and Ci is 1, how the subtraction will be done? 0 minus 0, 0, difference is 0, borrow is 0, and Ci is 1, so this 1 will come here. So 0 minus 1, as per binary subtraction, difference will be 1 provided there is a borrow also. That's why the combination, this 0, 0, 1 combination will generate the output 1, 1. See here, 0, 0, 1 generates the output 1, 1. Similarly, the remaining combinations, all the outputs are listed like this only. What we got in difference, we got output 4 times 1. See here, 1, 2, 3, 4 times. I have circled them. For borrow also 4 times we got the output high. I have circled those. Now from this truth table we have to write one sum of product equation for difference as well as borrow. Then from that we will come to know which are the logic gates we need to generate this type of circuit. So first we will see for the difference. So for the difference, I will club this 1, 2, 3, 4 terms. What is the first term? See here, this is first. I am getting difference, output high. What is my combination? A is 0, B is 0, Ci is 1. That means I can write A bar, B bar, Ci. See here, A bar, SOP equation for difference I am writing now. So first term is A bar, B bar, Ci. What is the next term? Next term will be 0, 1, 0, means A bar, B, Ci bar. So A bar, B, Ci bar. Similarly, the another 2 terms are listed, A B bar Ci bar plus A B Ci. Then these two which I have underlined, I am taking common a bar. What comes inside is b bar ci plus b ci bar, plus in these two common I am taking a common. What comes in the bracket is b bar ci bar plus b ci. If I see from, it is exactly same as a full adder. If you have seen the full adder video you will come to know ki this SOP equation for the difference is exactly same as full adder. What comes in this bracket is a XOR gate of B and Ci. Here this is a XNOR gate of B and Ci inputs. So if I assume this B XOR Ci as a X, my whole equation will be A bar X plus AX bar, which is nothing but the Boolean expression of XOR gate only, which having inputs A and X. So this equation will become A XOR X. But what is X? X is nothing but B XOR Ci. So this will be replaced by this term and my difference equation will come A XOR B XOR Ci, which means that for this difference I have to use A XOR B XOR C. That means for this I need one XOR gate to achieve this particular outputs. That is the meaning of this. Now for the borrow, again borrow also I have to write one equation. Now here also 1, 2, 3 and 4 terms I am getting the output high. Now for that also I will solve. Now if we solve that equation, see the equation will be, I have clubbed those 4 terms again, A bar B bar Ci, A bar B Ci bar, A bar B Ci plus A B Ci bar, Ci sorry. Now I am clubbing first and last. Now why I am doing this? Because so that I want that only whatever gates I have used for the borrow operation, those are XOR gates, so I can utilize the same hardware. I don't want to increase the hardware. That's why I am clubbing this first term and the last term. So if I club this, see my equation A bar B bar Ci, I am just adjusting this last term I have clubbed over here A B Ci. Remaining 2 terms I kept as it is aside, just adjusted this first equation, nothing else, nothing great I have done. Now in this I have taken Ci common. What goes inside the bracket is A bar B bar plus AB, plus here what is in common A bar B, what goes inside the bracket is Ci bar plus Ci. Now this is nothing but the Boolean expression of XNOR gate having the inputs A and B. So this becomes, equation becomes Ci dot A XNOR B plus A bar B. This term by the Boolean algebra rules, Ci bar plus Ci is equal to 1. So this bracket will vanish. Only A bar B will remain. So my the equation for the borrow is Ci dot A XNOR B plus A bar B. So what gates I require for this? For this I need one AND gate. For this I need one XOR gate plus one inverter I require, that is the NOT gate. For this I require again one NOT gate and one AND gate because it is a dot B bar hai, and this plus sign hai, that means I require one OR gate. So I need so many gates for doing this borrow. So when we club this both the equations and will draw the circuit diagram will be like this. So this is the actual circuit diagram of full subtractor. This is A, B, Ci. So this is, I am using 7486 IC. All the ICs, all you are aware of the ICs. I have used those ICs in internal diagrams I have shown in the full subtractor, full adder video. So you can refer those IC diagrams. Those diagrams are like this. 7486 is XOR gate. I am using this 1 2 3 combination. 7432 is OR gate. I am using this 1 2 3 combination. 7408 is AND gate. Again I am using this 1 2 3 combination. I have to use inverter. So inverter IC is 7404. So I am using this 1 2 combination plus I am using this 3 and 4 combination also. So this is input A, this is output A bar. So these are the gates I require. So see how the connections are. A, B. Here I am getting A XOR B. For difference I need A XOR B XOR C. I don't have a 3 input XOR gate, so I am connecting this output of the first gate to the input of the next gate. So that's why this 3 and 4 will be shorted. CI is the pin number 5 that will be connected over here. So this upper portion will generate the difference, that is A XOR B XOR CI. The borrow what equation we got is CI dot A XOR B. Now here I am getting XOR, that is A XOR B. Now in order to generate XOR I have tapped this point, and then further it is connected to the inverter. So inverter will give me here A XOR B. So here my output will be A XOR B. This I have connected to the AND gate, which is 7408. So this pin number 2 of the inverter will be shorted with pin number 1 of this AND gate. Then I need A bar B. So this A point is tapped. Again an inverter is used, pin number 3, pin number 4 out the inverter, because here I am getting A bar. That A bar is connected to the 7408, that is AND gate's pin number 4, while pin number 5 is directly connected to the B. So this AND gate generates A bar B, while this AND gate generates Ci dot A XOR B. Further we have to add them to get this equation. That's why this is given to one OR gate 7432 pin number 1. This A bar B is connected to pin number 2 of the OR gate, and therefore this OR gate will generate the output as Ci dot A XOR B plus A bar B. So this particular circuit we have to mount on the breadboard and check whether it works as per our truth table or no. So the circuit is this. I have mounted the circuit already. So here if you compare with the full adder, I had used one more extra IC, that is 7404, that is inverter IC. So this is my XOR gate. The first one is XOR gate. Then this is the inverter IC 7404. Then this is the AND gate, and then this is the OR gate. Now we'll test it with the truth table. Before that, let us see whether power supply connections and all are proper. So all 4 gates are there. So for all the 4 gates, this red wires, if you see, all are connected to the power supply ka positive. This positive of the power supply is connected over here on top. So these power supply connections are connected over here on top as a positive, while all this pin number 7 of all the ICs are connected to the ground, because this is power supply's ground, which I have connected to the last pin of the breadboard. So this full line, last line, bottom line is ground actually, and this is input A. Red one is input B, this green one is A, red one is B, and this black one is Ci. So these are the inputs which we have to connect to the logic 1 and 0 and check the output. This particular LED, this LED along with this series resistor is generating showing the difference output, while this particular LED is showing the borrow output. So we'll cross check the truth table along with our circuit. So let me put it on the supply. So if you see here, this difference LED is high, borrow LED is also high, and as I have told you, all these 3 inputs are open, so they act as high. So when, see the truth table, when A is high, B is high, Ci is high, my difference is also high, and my borrow is also high, and that is cross checked over here. My all the inputs, this is A input, this is B input, this is Ci input, they are not connected anywhere. That means they act as a logic high. My difference is output is high, and my borrow output is also high. Now so this my step is cross checked. Now let me check 1 1 0, means Ci I will connect to the ground, Now Ci is nothing but my this black wire. So this black wire I will connect to the ground, and if I connect to the ground, you check both the LEDs are off. If you see the truth table, 1 1 0, see here, A is 1, B is 1, Ci is 0, and my both LEDs are showing me the result 0 0, and my truth table also shows me 0 0. So this tape is also cross checked. So similarly you can check the remaining outputs also. Suppose I have to check the input, let us say this 0 0 0 1, this I will check the output. Let's see how it is. So I will make the connections as per that. So A I have to make it 0, so A I will make, I am making 0, B also I am making 0, yes. So the connections are, see here, A is made 0, B is made 0, and Ci is open. That means I'm checking this 0 0 1. So I expect difference should be high, borrow should be high, and I'm getting difference is high and borrow is also high. So in this way you can check the truth table of the full subtractor and check the outputs over here on this practical circuit of full subtractor. So you will come to know how exactly what is there in this block so that it generates this type of outputs. So hope you have understood this video. Thank you.